Hey everyone, and welcome back. In this lecture, we'll take a look at how to use the Data Analysis Toolpak add-on to return some descriptive statistics about data inside of Excel. So also in this lecture, I'll introduce and explain some key terms that you might come across, such as standard deviation, sample variance, kurtosis, skewness, standard error, and more. Let's get started. And again, for this lecture, we'll be using the sample sales dataset that we've been using throughout this section. So, let's say that we want to generate some descriptive statistics about our price column. And to do this, we can use the Data Analysis Toolpak, which is a very helpful add-on for Excel that not many people know about or use. To use the add-on, we'll first need to enable it. To do this, we can head over to File, and then Options, and then from within this menu, we can select Add-ins, and then at the bottom, ensure that you have Excel add-in selected, and then click Go. If it isn't already selected, make sure you enable the Analysis Toolpak option. And then now, when you go to the Data tab, off to the far right-hand side, we'll find a Data Analysis button under the Analyze group. And then if we open this up, we'll get a list of various different options. And from this list, we want to select the Descriptive Statistics option. To start with, we need to enter our input range. And this is the range of cells that we want to perform descriptive statistics on. So in our case, this is the price column, which is column C. So we'll click on this little button over here, select our first cell, which is cell C1, and then again we'll use Control plus Shift plus down arrow to select all the other cells with data in this column. We can then hit Enter, and that will enter our cell range. And then we need to tell Excel how our data is grouped. So either by columns or by rows. If your values are stacked in a column, like ours are here, then we can say that our data is grouped by columns. But if your data is entered into multiple cells, so stretching across a single row, so in other words, our data is in a single row going from left to right, then the data would be grouped by rows. And as we have a column heading in our first row, it's important that we check this box here that says labels in first row. And then for our output options, we get to choose where our descriptive statistics are turned to. The output range allows us to put the results in the same worksheet that we're currently in. The new worksheet ply option lets us create a new worksheet within our current workbook. Our new workbook will create an entirely new workbook. So I'll use the second option and create another worksheet within the same workbook. Underneath this, we then get to choose what statistics and outputs we would like. And to better demonstrate what they all do, I'll select all of them, and then that way we can go through what each of them are and how to interpret the results. So let's go ahead and click OK, and here are our results. So let's now go through and look what each of these numbers mean. First, we have the mean, and this is just the average of the set of numbers, and it's calculated by adding all the numbers up and then dividing by the count of numbers. Next, we have the standard error, and simply put, this is a measure of how much the sample mean is expected to vary from the true population mean. The higher the standard error, the higher the variability. The median is the middle value in a sorted list of numbers. So half the numbers are below the median, then the other half are above. Then we have the mode. The mode is the number that appears most frequently in a dataset. If your dataset doesn't have a number that appears more than any others, you'll get an NA error. Next, we have the standard deviation, and this is a measure of the amount of variation in a set of values relative to the mean. A low standard deviation indicates that the values tend to be close to the mean, and on the flip side of that, a high standard deviation indicates that the values are further away. After this, we have the sample variance, and this is linked to the standard deviation, in that it is the square of the standard deviation, and it's a measure of how spread out the numbers in a dataset are. The next two statistics we have are the kurtosis and skewness, and these two terms are particularly relevant to data scientists and statisticians. And while data analysts might not engage them as much, they do still offer some valuable insight into the shape of a data distribution. So the definition for kurtosis is a bit of a full-on one. It is a statistical measure that describes the heaviness of the tails in a probability distribution of a real valued random variable. And put in simpler terms, kurtosis quantifies the extent to which the tails of the distribution differ from the tails of a normal distribution. So this includes the presence of outliers, with higher kurtosis indicating more outliers, so heavy tails, and a lower kurtosis suggesting fewer outliers, so with light tails. To illustrate what this actually means in practice, let's have a look at two different graphs with varying levels of kurtosis. So looking at our graphs here, we'll notice that they form a shape, often looking like a hill or a mountain. Kurtosis is a way to describe how tall and skinny, or short and wide that hill is, especially at the ends or the tails of the hill. High kurtosis means that the hill is taller and skinnier, with most of the data bunched up in the middle, but with some extreme values far away from the middle. These extreme values happen less often, but are more extreme when they do. And low kurtosis means that the hill is shorter and wider, with more data evenly spread throughout and a few extreme values far from the middle. Skewness, on the other hand, refers to the asymmetry of the data distribution. A skewness of 0 means that the data is symmetrical. Values of -1 to 1 indicate that the data is fairly skewed, whereas values that are either less than -1 or greater than 1 indicate that the data is highly skewed. Positive or right skewed data is when a distribution has a longer tail on the right. And with positively skewed data, the majority of the values tend to be on the left, with a few outliers stretching out to the right, as we can see here. The opposite is of course true for negatively skewed or left skewed distributions. In the middle here, we have a graph with a skewness of 0, so perfect symmetry. So in summary, kurtosis is about how extreme the outliers are, while skewness is about which direction the data is mostly leaning towards. Next, we have the range. Range is the difference between the smallest number and largest number in a dataset. Then below our range, we have the minimum and maximum value. The difference between these two numbers is 73.12, which is the same as our range. The sum is then just the total value returned by adding all of the numbers in the dataset together. Count is the total number of values in a dataset. Then next we have the largest and smallest. During the setup process, we enabled the kth largest and smallest option and used the default number provided of 1. So this then returns the first largest and first smallest number in our dataset, which is why it has a 1 after it. This is why these values are the same as our minimum and our maximum. But if we had entered 2 for our kth largest and smallest options during setup, we would get the second largest and smallest numbers from in these cells. And then finally, we have our confidence level, which is often called the confidence interval. And this is basically a range that we give for our estimates so that we have some safety margin for any error we may have made. Imagine that we're trying to figure out the average height for students in a school, and we believe that the answer is 153 centimeters. The confidence level tells us how sure we are that the real average is that value. So if we had a confidence level of 95%, that gives us a margin of 5%. So 5% of 153 is 7.65, which allows us for plus or minus 3.825 centimeters, which is just 2.5% on either side. So this then makes our answer 153 centimeters plus or minus 3.825 centimeters. Okay, and that's everything here for our section on the data tools available within Microsoft Excel. In the next section, we'll have a look at some of the most important functions, what they do, and how to use them. So I'll see you there.